Howdy guys, welcome to another stats video. Today we're going to talk about hypothesis tests, p-values, and null and alternative hypotheses. A statistical hypothesis is an assumption about a population parameter. And remember, or maybe don't remember, we're going to be learning. A parameter is a true mean or proportion about a population. This assumption may or may not be true. So we're going to make an educated guess that may or may not be true, and we'll talk about the formal way that we do that, because we do the same kind of setup, if you will, for every problem. Hypothesis testing refers to the formal procedures used by statisticians to accept or reject statistical hypotheses. Always had a hard time saying that. Statistical hypotheses. The null hypothesis, represented by the symbol H naught, that little zero, sub-zero, we read H naught, is a statement that there is nothing happening, status quo, no relationship or no distance from assumed population parameter or parameters. In most situations, the researcher hopes to rebuff, which means reject, the null hypothesis. Null hypotheses, that should be an E there, can be written using words or here it is again, statistical representation if symbols are defined. So H naught could be that mu is 72, where mu is the population mean height of college males in inches. Or H naught could be that P is equal to 0.2, where P is the proportion of Austinites who prefer taco deli to Torchy's. The alternative hypothesis, represented by the symbol H sub A, or HA, some people say, is a statement that implies something is happening, a relationship exists, or there is a difference. If we use statistical representation symbols, only three options can occur: less than, not equal to, or greater than. So the alternative is a difference. It's not that mu is equal to something, it's that mu is less than something, or mu is greater than something, or mu is not equal to. Same thing with p's. So let's look at this first example. You know what? Let's add a couple things up here. These always have an equal sign. So H naught is the parameter is equal to what everyone says. That's layman's terms. But it's that nothing exotic is happening. We haven't showed anything. H sub A is what the researcher thinks is true. The other thing that's worth noting is H sub A always uses the same numbers, or same number, as H naught. So these guys match, right? You're always going to have a null and an alternative hypothesis that match each other. There'll be mu's and there'll be 72s. Or there'll be p's and there'll be 0.2s. I'll show you how this works a little bit. On a given hospital shift, there's a 4.5% chance that a death occurs. The prosecutor believes that deaths are occurring more often when Kristen Gilbert is working. So what's the null hypothesis? Well, it's going to be H naught. The proportion of shifts with deaths where Kristen Gilbert is working is 0.045. That's 4.5%, right? The alternative, so this is the null. The alternative is going to be what we think is true. So this is going to be the proportion of shifts. The wording will be almost identical with deaths where Kristen Gilbert is working is greater than 0.045. Why greater than? Well, that's what we believe is happening more often, occurring more often, meaning the proportion is higher than 0.045 or greater than 0.045. The p-value is the probability of observing a given. So next little piece is the p-value. So the p-value is the probability of observing a given sample statistic under the assumption that the null hypothesis is true. So if the null is true, what's the probability of getting an observing a specific sample statistic that we are given? So I'll show you kind of what that looks like. The significance level denoted alpha. Okay, that's like a script A, right? Greek letter alpha. For a given hypothesis test is a value for which a p-value less than or equal to is considered statistically significant. So we're going to have different significance levels, just like we had different confidence levels when we talked about confidence intervals. If the p-value is lower than alpha, we reject the null hypothesis. If it's higher, then we fail to reject the null hypothesis. Most hypothesis tests are done with a 0.5 or a 0.01 significance level. So it's sort of like the complement of a 95 confidence level or a 99 confidence level when we talked about confidence intervals. So the p-value in the Kristen Gilbert case was 0.0000, lots of zeros, one, little bitty. Interpret the p-value. So here's, first of all, what does this little piece mean? This means that we reject the null if we observe something that has less than a 5% chance of happening. Or 1%, depending on which one we're talking about. If we're talking about this significance level, 0.05, that's what that means. It means if we've got this null hypothesis and we've got this alternative hypothesis, and if we get a value and we look at it and we say, okay, how likely is this value to have happened if we know the null is true? Well, if there's less than a 5% chance of it happening and we're using a significance level of 0.05, then we're going to reject the null, okay? So the way we're going to interpret this, if deaths were still occurring on 4.5% of shifts, there is a 0.000, how many zeros is that? 2, 4, 6, 1 chance of observing let's say 40 deaths or whatever the number is, the number that actually occurred. They give you that value, whatever that is. All right. So the conclusion is, because that p-value is so small, and if p is less than alpha, we reject, then we're going to say we reject the null hypothesis and conclude that the proportion of her shifts with deaths is more than 4.5%. And depending on what class you're in, they can get really picky about how you make that conclusion. This is going to be good enough for us. It's not that huge of a deal. All right. Tomás. Suppose the national average score on a certain standardized test is 1070. You want to investigate whether AISD students are performing close to the national average. What's the null? The AISD average is equal to the national average, 1070. The alternative would be the AISD average is not equal. So in cases like this, where it's not clear if we suspect one way or the other, less than or greater than, we're just going to use not equal to. Let's suppose that you randomly sample 50 students and they have a mean of 1075 with standard deviation of 20. After study, you get a p-value. So this data, this random sample of 50 students with a mean of 1075 and a standard deviation of 20 gives you a p-value of 0.21. Well, they want us to interpret this. If the AISD average is